In this video, we're going to look at what constitutes and how to add like radicals. Now when I say a like radical, I mean two square roots or other roots that can be added together. In order to have a like radical, we have to have the same inside, so that's this part, has to be the same, and we have to have the same index, this part right here. If we have an ordinary square root, then we just usually leave that part off. But whatever we have to have, whenever we have two like radicals, that has to be the same. Okay, now if we want to add two like radicals, then the question we have to ask ourselves is, can we make them the same if they're not already the same? Well, what are some examples? Let's take a look at, let's say we have 2x plus 1 and 3x plus 1. These are not like radicals. They're not the same inside. What if I have the square root of 2 and the cube root of 2? Well, this is 1.4 and this is 1.2, 1.3, I'm not quite sure, but they're different numbers. So they're not like radicals. We can't add them. Now, what if we have, the trick is, sometimes we have these expressions and we can simplify them. For instance, if we have the square root of x cubed. Now the trick here to understand is that x cubed is really, here we have the square root of x squared times the square root of x. The square root of x square root of x squared, that's x squared 1/2. Of course, those are our rational exponents. Really, so the square root of x squared is really just x. So x cubed, the square root of x cubed is x times the square root of x. That's as much as we can simplify it. Now let's look at some more concrete examples. Here we have 3 times the square root of 8 x to the 5th power plus 2 square root of 2x. Are these like radicals? At the moment, no. But can we simplify them? Let's take a look at this one, the more complicated one. The square root of 8. Well, 8 is 2 times 2 times 2. The square root of 2 times 2 is 2. So I'll pull that out in front, put a 2 out there. X times x times x times x times x. And pull x out. I can pull another one out. I'm left with 2. Of course, our x are x squared times our 3. So 2 times 3 is going to give us 6x squared. What we have left in here, only 2 and x, so we have 2x plus 2x from right here. Now, do we have like radicals? The insides are the same kind of roots. Yes, these are like radicals. Like terms. We can add them now. And we get 6x squared plus 2x. Okay, let's look at another example. Can we simplify this one? Notice here we have a cube root because of the 3 right there. Any like term would also have to be a cube root. A square root or a 4th root or a 5th root or any other kind of root won't do. It has to be a 3rd root. Now here we can see how these are just like polynomial-like terms. If I want to add an x and an x squared, I can't because they don't have the same exponent. Don't worry too much about that right now, but that's the reason why we have to add the same kind of root. Now, if I want to, the trick with, like I said, the trick with adding these is simplifying first. That's the whole trick. That's the hard part. So, can we simplify this? That's just what I'm focused on right now. 16 is, let's see, the square root of, or actually, no, it's the cube root. So we want to do, let's give ourselves some more paper to work with. Okay, cube root, focus. That's 16x to the 5th. 16 is 2 times 2 times 2 times 2. Or I can write it as 2 to the 3rd power times 2. X to the 5th is, I'll write it as x to the 3rd, x to the 2nd. And of course, all this in a cube root. Now, the cube root of 2 cubed, cube root and to the 3rd power cancel each other out. So I can pull u out in front as a 2. X cubed, likewise, go out there. We're left with 2x cube root. What we have left? What we have left is, you can't tell that's a different color. The 2 and the x squared, leaving us with 2x squared. Now, if we tried to add that to any other like terms, for instance, maybe 3y, then yes, here we have like terms now.